Okay, we're looking at question number 6 of the AB exam from 2021. I'm solving this in real time, so you're watching me think through it. I have not read it yet. So, question number 6, a medication is administered to a patient. The amount in milligrams in the patient is modeled by the function A of t that satisfies the differential equation. dy dt is 12 minus y over 3. So dy dt is 12 minus y over 3. At time 0, there are 0 milligrams of medicine in the patient. So, and they do say that A is the amount. So my amount at time 0 is 0. They did not ask a rate in, rate out question this year. It hurts my feelings. All right. So a portion for the slope field below is given. Sketch a solution through the points 0, 0. Okay. I'm not supposed to include screenshots of the actual question, so I'm just going to show you what mine will look like. I'm starting at the point 0, 0, which is here. It looks like we have an equilibrium solution up here, so we have a horizontal asymptote as you work your way up, and it looks, for those of you who know what a logistic curve, this is going to be kind of logistic. It's just missing that concave up portion at the beginning. You should have something that looks kind of like that. Your solution should have looked like that. That's a nice question. All right, number B. Use correct units to interpret the meaning of that in the context of the problem. Again, this one is not going to be too bad. I should not have opened that thing. Okay, so B, the limit as t approaches infinity of a of t equals 12. And they tell you that a of t, I'm scrolling up to read the problem, that a of t is the amount of medicine in the patient. So, as time approaches infinity, the amount will be stuck at 12. Really? Seems like it would eventually dissipate and there will be none left. What kind of medicine is this? It's always present in the patient. The amount in milligrams of medication in the patient at time t hours is modeled by that function. Okay. So interpreting the limit in the context of the problem, you do want to be specific with your descriptions and what a of t is. So as time approaches infinity, this is really baffling to me. It doesn't seem logical in the medicine world, but I'm no doctor, so what do I know? No pharmacist here. As time approaches infinity, the amount of medicine, and I'm going to put in words what a of t is. I could say a of t is approaching 12, but I want to put in words what a is. I'm going to copy that strictly from the paragraph. So the amount of medication in the present in the patient, the amount of medicine in the patient will approach 12 milligrams. The medication amount. So they don't tell you that they're going to stop and re-administer it or anything like that. As time approaches infinity, the amount of medicine in the patient will approach 12 milligrams. Okay. Cool. All right. So number C, use separation of variables to find the function a of t. And this was fairly predictable. For this one, I think, before I start separating, oh, no, I won't. I'm sorry. I was about to make a really poor decision. So when I separate, I'm going to make one tiny change to the right side. I'm going to call it 1/3 of 12 minus y. And then when I separate the variables, I will divide by the 12 minus y, and I will multiply by the dt. You could bring the 3 over if you want to, but it's really not going to help you. Now we need to do the antiderivatives of both sides. My left side will be a natural log, but only after I put a -1 in the numerator. So we have negative natural log 12 minus y is equal to t over 3 plus c. And now we have to solve for y and we have to solve for c. I generally, if I have a natural log, like to solve for the y first, and we'll do that by moving the negative over, make that negative t over 3 plus c. Technically, the gods of math want you to indicate that this C is a little bit different than the previous one. On the AP exam, they're not going to be that picky, so I'm going to just put plus C. Plus C. Let's see. Then I will use E to get rid of the natural log. So we'll have 12 minus Y is equal to A e to the negative t over 3. I do know that my amount at time 0 is equal to 0. So 12 minus 0 is equal to A e to the 0, which tells you that A is going to be 12. So now 12 minus Y is equal to 12e to the negative t over 3, and then we will finish solving for y. It'll be 12 minus 12e to the negative t over 3. And sometimes when I talk while I work, I make careless mistakes. I'm going to double check that really quick, although I feel good about that. Yeah, I feel good. I'm going to stop there. So there's my answer for C, and we're done. I'm not a big fan. I don't like my answer for B. Something just doesn't seem to be sitting right with me there, but I think I'm just going to leave it like that. All right. We're done. Okay, I'm coming back to do part D. I thought part C was the end because on the PDF I'm looking at, D was on a separate page. So let's finish question number 6. A different procedure is used to administer the medication to a second patient. The amount in milligrams of medication in the second patient at time t hours is modeled by B of t, which is that differential equation at time 1. There are 2.25 milligrams in the second patient. So for part B, it's B of t now. So B of, in 1 hour, there were 2.5 milligrams of medication in the patient. Is the rate of change of the amount of medication increasing or decreasing? Okay. So when I see increasing or decreasing, I'm thinking derivative positive, derivative negative, and they're asking about the rate of change. So this is really a second derivative question. And so once again, we get to do the second derivative implicitly. We did this in an earlier question. I think it was just number 5, if I'm not mistaken. So dy dt is 3, and I'm going to say plus negative y. I'm just going to put that negative up there, over t plus 2. And so I'm going to need the second derivative of that. So d squared y over dx squared will be 0, and then I have a quotient rule. So low, and d high is negative 1, but we have to do implicit there. So that's negative 1 dy dt. So that's low d high minus high. D low will just be 1 over low, which is t plus 2 squared. And now we plug in the point. We're concerned. Let me make sure. We're going to plug in the points 1, 2.5 into that second derivative. So my second derivative at the ordered pair 1, 2.5 is going to be 1 plus 2, which is 3. And then for the dy dt, I'm going to come over here and figure out what dy dt is. So dy dt is 3, at that point. 1, 2.5 is going to be 3 minus 2.5 over 1 plus 2, which is 3. So that's 3 minus 2.5 over 3. You know what? I'm just going to leave it like that. Should I clean that up? I think I will. I'm going to make that get a common denominator. So 9 minus 2.5 is 6.5 over 3. And I'm going to plug that in up here. So 3 times negative 1 times 6.5 over 3. So negative 6.5 over 3 minus a negative y, and y is 2.5, times 1. So that's going to be plus a 2.5 all over 1 plus 2 squared would be 9. And I simply want to determine if this is positive or negative. So the 3's here cancel. This will be plus negative 6.5 plus 2.5 will be negative 4 over 9. That is a negative value. Therefore, the question asked, is the rate increasing or decreasing? Therefore, the rate of medication, the rate of change of medication in the patient is decreasing at time t equals 1. And there we are. So now I'm finally done with part 6. I called this B. This is a D way up here. All right, so we're done.